So today I came to one of the areas in Taipei where the ecosystem of electronics is um, super active, and they custom make computers, they sell you refurbished phones. Besides of showing you the little bear holding a phone and a laptop, there is here one small shopping mall. I'll get in. They have several floors, but there's one I'm especially interested in showing you. So you can see that, right? Switches, batteries, all kinds of lights. And here you have a little bit of a description, right? Like 电子零件, and elements for the computers as well. So this is not something unique to Taipei. There's a series of electronic markets in different cities in China. Huaqiangbei in Shenzhen is one of the most famous ones, but the kind of tools they have here in Taiwan it's a little bit different. They have a set of development-oriented tools, and they have small shops where you can buy just a little tiny bit of what you need. Outside you can see that it's all cables, and you are going to see a number next to it, like that. So cables is one of the things that we are going to be using in our course. There are several specifications for them. I don't want to get in detail. If we are going to be talking about a wire, it could be solid core. So if it's solid core, you're going to see that it's not that flexible, and that might become handy, for example, in a situation that you are using it on a breadboard, you want to insert it. But it's not that flexible, I said. So that means that long term, if that's going to move a lot, it might break. You will find that others, whether inside of the isolation that it has outside, the plastic cover, it has either one or several of these cables. So one like this, it has two. You'll see that these are very common for you to use inside of your house, and they're rated outside on the outside plastic cover, saying that it can tolerate, that plastic can tolerate 250 volts, for example, or 600 volts. This is so many AWG. So let's look at this one. It's multi-threaded 22 AWG, very thin. And let's look at this one to make a contrast. And it says 2.8 millimeters. So let's look at the assortment of options. This one is 18 AWG, mostly used for audio, very low voltage the rating. Here this one is 22 AWG, but it has an outside cover that's very thick for 600 volts. And you can see there's different configurations. There is one with blue cover, or this one is the 12 AWG that's more expensive because it contains more copper. And some of the cables, they are for special applications, so the shape is different even. See, this one is 2.8 millimeters of diameter of the core, and that means that it's each one of them. So then there are 3 wires in this configuration, or they also sell you like this, 2. And there are many different ones. It's impossible to go all over them. But let's look at one more example. Like this one is rated 1.2 kilovolt, 22 AWG. So not so much current, but actually high voltage. So let's look at the shop inside. Has these little trays and it's full of components. So let's imagine that you want a switch. So they sell you many kinds of switch. These here I have in my hand, it has 3 terminals. So they switch the one in the center to each of the ends and they have different sizes of the hole where you're going to install it, or different current capabilities, or different voltage. For example, this one is just like on-off, but there are others that have like middle position where nothing is connected. So there's a level of jargon as well on how to call them. This one I have here has 3 terminals, and you can see it's a single pole double throw, because there's one central terminal and 2 on the side. So people might call these SPDT, right? And there's all these other things, right? Like look, there's some that made for the industry that they're very robust. Some that comes with a key or light inside. This one it comes with a joystick shape, so you can use it in an arcade console. And some of them, they have 2 colored lights inside, so when you press, you know that there's state, so there's a visual feedback, and everything depends on the application. This one is for safety. You have to hit it to deactivate it, or you have to turn it in order to turn it on. We have one of those at the DigiFab. Most of them will have 2 terminals, so it's just a switch, just it's momentary, right? Like it's just for an instant. It will connect when you push it. Some of them will have 4 terminals because they're double, right? There are 2 circuits inside. Some will have 6 because they're double, and also they have terminals for the lights. So here they have the ones that are designed especially for 250 volts, the ones that we have in any house appliance, and you can see they turn on, and some of them they have a light inside. And let's look at this one. It's a double pole, double throw, so DP DT. And if you ask for DP-DT, they just point you at the right section, and you need to select them according to the current and voltage you need. Look at the jungle that is this, right? I will just like go over. I asked the owner for permission and to film a little bit the components of the shop. He was actually pretty happy. So let me say, all these drawers are all resistors, different kinds. So let's look at one of 10 watts that is like a monster, right? It's enormous. 10 watts, imagine P equals V times I, so I is big. There's a maximum voltage for each of these. That comes in the specifications, but in general, the little ones, like the ones that you have in your kits, it's like 200 volts. So it's also fair to say that one of the reasons that there's so many kinds is that the price is related with how many watts they can dissipate. So the bigger they are, the more expensive they are. And these ones that I have here, they have like 1 watt divided 16 as the maximum power to dissipate, are the ones that you most likely will have in your kit. The ones I have holding in my hand, the tolerance is 5%, right? So you can see they have written on the bag how many kilo ohms they are, and the colors indicate that as well. Here you have capacitors, some electrolytic capacitors. They just have them here like laying around. I think that they weighed them to measure the quantity. They also sell boards like these. They have an assortment of resistors and capacitors, so you can tune up your circuit as you need. And the ones here at my right are all integrated circuits. It's like all the most common parts that you might need. And let me see, what do we have over here? Again, we have different kind of knobs, and there's also here terminals, so you can connect the wires to your circuit. And here you see that all these diodes, right? You can see the part numbers there. Let's see one that is the most common one, like this is 1N4148. This is a small signal rectifier, and these are all inductors. So see the values, 220 microhenry, and the value, the one I see here, the smallest one is 0.22 microhenry. And for each one, they sell a very tiny one, again, very low watts it could dissipate, and a bulkier one, maybe 10 times more expensive, but the dissipation, the current that it can circulate is much bigger. And the values range between some microhenry to the hundreds of microhenry. Maybe this will be an enormous one of 1 millihenry. Over here, you can see they have all these terminals again, and there's some fuses as well. I see over there. And so anything you need to connect with your circuit will need to have the proper terminals. And here they have again more cables, transformers there. All this area is for fans. So if you have something that's dissipating energy, you need to make the air circulate. Let's go over here. Oh, capacitors are here. So there are different configurations. They make them with different materials. These are aluminum electrolytic capacitors. So they are polarized. You need to pay attention where is a negative terminal. And these, for example, these are polyester. So one of the differences is that polyester generally they tolerate higher voltages, and the polarity can be reversed. That in the polarized ones you cannot. And you can see the labels, right? This is like this 564. And then you can see there's a rating about the voltage, the maximum voltage you can tolerate, in the same way that the electrolytic capacitors have it. So the electrolytic, you can see, like, okay, it says how many microfarads, so many volts. The polyester, they say a number that is referred to how many picofarads. So that means there's the third number is going to multiply times 10 minus 2 to calculate in farads. So these 563, the 3 refers that it's 1,000 times bigger than picofarads. So you read 56 nanofarads. You just scale one dimension back. 27.3, 27 nanofarads. If it says like those, 274 is 270 nanofarad. So, well, I was saying that this is jungle, right? Like it's full of components, and there's no way that we cover all of them. But I think that it's important that you know that this exists. So, for example, here they have some materials that you are familiar with. Look, did you ever work with something that had a display? And here, for example, you have buzzers, right? So the ones that had the interaction lab, you know that one very well. It makes a beep beep sound. And these are microphones, right? So these, you can see, it doesn't have terminals. That's for mounting it with surface, like, so it's SMD. But this is PTH because it has the pins out and it will be pass-through hole. And look what a beauty I found here. This is what this is a piezoelectric. I will put some on my cart, and then you find an ultrasonic piezoelectric. Now here there's one. The resonance, well, it doesn't say, but it's probably like 100 kilohertz, and there's a lot of assortment of things here. Look, this is called a 7-segment display, so it can show numbers, and this one, it's meant to build a matrix, right, of dots. Each of those contains a light, contains an LED. So they have different configurations. That one comes with 3, and it's full of interesting things, right? Because I didn't work with all of them. Depending what are you doing, what kind of things you have to use. Look, these are crystals. So it's also a piezoelectric, but it vibrates in a very calibrated manner. So you let it oscillate in the circuit, and then it resonates in a very precise frequency. So that means that all your watches have one. All your computers have one of those, because that's going to be like the master of timing, right? So there's a rock, there's a piece of quartz that will oscillate, and it's very precise. So in this sector, you can see that all the tools are here, right? From a breadboard, Arduino sensors, and whatnot. Let me show you one thing, and it's wire wrap. Right? So these very thin wires are excellent for you to prototype, for example, with a breadboard. So you don't mess up which signal, which color, like you have different colors for everything. So this is the little tour and embedded lesson that I thought that we could have. I hope that you enjoyed it, and maybe it makes you curious, and when we are in Shanghai campus we can do our small field trip to the Saigo, to the electronics market over there. See you.